All right, this is Honors Algebra 2 Pre-Calculus. We are doing 8.2 in Algebra 2, which is rational functions and their graphs. So this is going to be a pretty long set of videos. This is a fairly important concept, and it's pretty detailed. It's going to build a lot on things that we already know how to do. So a rational function is any function that can be written as f of x equals p of x over q of x, where both p of x and q of x are polynomials. So we learned about polynomials a lot in Chapter 7. Essentially, something is a rational function if it is a fraction of two polynomials. In 8.2, we're going to learn a lot about these functions, including how to graph them by hand without a calculator, which definitely comes in handy for AP Calc. So, stuff we're going to cover in this video: finding the domain of a rational function, finding the vertical asymptote or asymptotes of a rational function, finding the holes of a rational function, finding the roots of a rational function, finding the y-intercept of a rational function, finding the horizontal asymptote or slant asymptote of a rational function, and using the above information to graph a few points and then graph the function. So there are three basic forms of these rational functions that we're going to use. Standard form, which is most useful for the things that I highlighted in yellow up here. So both of the polynomials are written in standard form with the powers of the variables descending. Factored form. So factored form is going to be the most useful for finding these first four things that we're going to need. And so that's basically where both of the two polynomials are completely factored. And then simplified form, which is after you factor, some of the factors can be canceled, leaving you a nicer, easier version to use. Whew, excuse me. So each of these is useful for some things, hence the highlight above, right? All right, so let's walk through. So here's a rational function. So you can see that we have an x squared minus 7x plus 12 on top, and we have an x squared minus 9 on the bottom. Standard form would have these polynomials both in the standard form. Factored form would have the numerator and denominator both fully factored. And simplified form would notice that the x minus 3 cancels from both of these, leaving you with this simple form. So let's walk through how we would find, using the factored form, we're going to find four basic things, okay? So using the factored form, we're going to find holes. So factors that cancel, right? Factors that cancel represent holes. So for example, in this particular problem, right, x minus 3 would represent a hole because that's a factor that cancels. So a factor that cancels out of the numerator and denominator represents a hole. We set the factor equal to 0 and solve for x. At x equals 3, this graph has a hole, okay? Factors that do not cancel from the denominator represent vertical asymptotes. So x plus 3 is 0. There will be what's called a vertical asymptote at x equals negative 3. So it's a vertical asymptote. Factors on the top that don't cancel are called roots. So this thing right here is going to be a root. So x minus 4 equals 0 is a root. X equals 4 is a root or a 0 of this function. All right. So that's why we want this fully factored form, right? So what's happening is this fully factored form very quickly gives us all three of those pieces of information. Because in the big four domain restrictions, you are not allowed to divide by 0. Any of the stuff that causes a problem on the bottom is automatically a domain restriction. So my domain is going to be all real numbers. So x is an element of reals, but x cannot be this thing or this thing. So we're going to say negative 3 or 3, and that's going to be my domain. So in this exact example, that's how we would find the domain, the roots, the vertical asymptotes, and the holes. All right, so let's go ahead and keep going. So here, we're going to go ahead and find the holes, vertical asymptotes, roots, and domain of this rational function. So I need to fully factor. So I noticed at the top, right, the front seats are definitely x and x, right? This is why factoring is super important, right? I see that my back seats has to be a 1 and a 2 with opposite signs, and I want a negative. So I think it's a negative 2 and a plus 1. And I should FOIL in my head to double check. X squared is correct. Outer would be a plus x, and inner would be minus a 2x. That comes out to a negative x. That's correct. And my last term would be a negative 2. That's correct. On the bottom, I see that I also have a 1 and a 2, but that they have to have the same sign, and that sign should be negative. So there's really not a lot of options here. It's definitely an x minus 1 and an x minus 2. So this is my fully factored form, and you can FOIL to check. X squared is correct. Negative 2x and negative 1x is a negative 3x plus 2, right? So now I'm going to go ahead and walk through what all these things are. Well, the factor that cancels, right, that's going to be a hole. So when x minus 2 is 0, x equals 2 will be a hole. Factors in the denominator that don't cancel are going to create problems. They're going to be vertical asymptotes, right? They're going to create essentially what's called a discontinuity, right? And then factors of the numerator that don't cancel are roots. So x plus 1 equals 0, x is negative 1 is a root. We're going to talk about what these things look like in a couple more pictures. So my answers, right? My answers are that my whole is where x is 2. My vertical asymptote is where x is 1. The root is where x is negative 1. And the domain is going to be all values of x except these two, right? So it's going to be x is an element of reals. X cannot be 1 or 2, right? So that would be my domain. The other way to write that, if you prefer the domain parenthetically, is to write negative infinity up to 1 but skipping over 1, 1 to 2 but skipping over 2, and then 2 to infinity. I think that's a lot more complicated in this particular instance. All right, go ahead and try a P2. Again, you're going to, a P1 rather, you're going to factor fully and you're going to find all of those values. So the first step here is to make sure you know how to factor and that you can do it fully. Again, don't care how you factor, I just care that you do it right and you do it quickly. So I notice that this has to be an x and an x on both the top and the bottom. So I spot that, right? I see that this is a positive 4, which means it's either a 1 and a 4 or a 2 and a 2, and it has to have the same sign. Well, the only way I'm getting a 5 out of that is if I have a plus 1 and a plus 4. And you should FOIL to check in your head. X squared, correct. Plus 4x plus 1x is a 5x, and then 1 times 4 is a plus 4. On the bottom, I see it's also either a 1 and a 4 or a 2 and a 2, but I see that they have opposite signs. That pretty much rules out the 2 and 2, because if they had opposite signs, this would be a difference of squares. There would not be a 3x on the inside. So since I want a negative 3x, right, I want a negative 4 and a plus 1, right? And you can double check that's right. X squared, outer is a minus, or is a plus x, inner is a minus 4x. There's my negative 3, and then there's my negative 4. So now anything that appears on both the top and the bottom will cancel. So that's a whole, right? When x plus 1 is 0, which will be at x is negative 1. There's a vertical asymptote when x minus 4 is 0, which is at x equals 4. And the root will be when x plus 4 is 0, which will be x is negative 4. Right? So if I write all my answers, right? So my answers, the whole is when x is negative 1. The vertical asymptote is when x is 4. The root is when x is negative 4, right? And I use these two together to get to the domain is all real numbers. So I can write x is an element of reals, but x can't be 4 or negative 1. That's one way to write it. The other way to write it, if you like it better, is negative infinity to negative 1, skip over negative 1 to 4, skip over 4 to infinity. I think it's easier to write it like this. All right, moving on. All right, so we're going to do this again. We're going to find all the wholes, vertical asymptotes, roots, and domain of the rational function. Again, the name of the game here is just to factor a lot. So when I factor, the first thing I should spot here is that the top has a GCF. If I take out a GCF of 2x, I'm left with x squared plus 2x minus 8. And on the bottom, there's a GCF of x, and I'm left with an x squared minus 4. So this thing is a difference of squares. And this thing is a quadratic trinomial. So I'm going to keep factoring, right? I have this 2x times, so I think it's probably a 4 and a 2 for the 8, because I see that they have to have opposite signs and add to a positive 2. So I think we have x plus 4, x minus 2. And you should always FOIL that in your head to double check. First would be an x squared. Outer is a negative 2x, and inner is a plus 4x. There's your plus 2x. And then a minus 8. And again, that's not something you have to do out loud. It's not something that you have to do visibly in any way for me personally. But if you factor wrong, entire problems get derailed pretty quickly. All right, so this is my fully factored form. What's going to happen now is I need to notice that there are actually two wholes, right? There's a whole when x minus 2 is 0, which is at x equals 2. And there's also a whole, because I can cancel that factor of x, right? So x equals 0 is also a whole. Any factor that doesn't cancel on the bottom is a vertical asymptote. So there's going to be a vertical asymptote at x plus 2 equals 0, which is x is negative 2. And then there's going to be a root when anything on the top is equal to 0, so x plus 4 is 0, which is x is negative 4, is a root. But 2 equals 0 is a lie, right? So that's not a root. That's just 2, that coefficient of 2 cannot be equal to 0. So when I answer this, when I want to list all these values, and I promise that it's going to come together a little bit more as we move forward, there are 2 places that there are holes here. At x is 0 and 2. The only vertical asymptote is at x is negative 2. What that means about the domain is that it's all real numbers, so x is an element of reals, but x can't be 0, 2, or negative 2. And the only root is at x is, sorry, not 2, my bad, looked up at the wrong spot, at x equals negative 4. All right, so that's our answer. Again, if you chose to write the domain in a parenthetical, it would be much longer, right? If you wrote the domain in a parenthetical, it would be negative infinity to negative 2, skip over the negative 2 to 0, skip over 0 to 2, skip over 2, and go up to infinity. Also fine, but a little bit long. All right, so we're going to find the holes and vertical asymptotes of this one, right? So go ahead and give it a try. Again, you need to fully factor. So I noticed that the top has a GCF of 5, leaving me with an x squared minus 9, which is totally, so we have this GCF, right? And then we have a difference of squares, right? And the bottom has a GCF of x, leaving me with an x squared minus 4x plus 3. So I think we get a 5. The top is an x plus 3, x minus 3 because of the difference of squares. The bottom has to be a 1 and a 3 with the same sign, and they're both minus. So I get this x, and then an x minus 1, x minus 3. All right, so now when we go to clean this up, I see that the x minus 3's cancel, so there's definitely going to be a hole when x minus 3 is 0, which is at x equals 3. But neither of these cancel, so I'm going to have 2 vertical asymptotes, one when x is 0, and one when x minus 1 equals 0, which is at x is 1. The roots would be when the stuff on top is 0. Well, either 5 is 0, that's a lie, because 5 is not 0, or x plus 3 is 0, which means x is negative 3. So those are my roots. So when we put this all together to get an answer, the hole is at x equals 3. The vertical asymptotes are when x is 0 or 1. The domain is every x value except those 3. So x is an element of reals, but you can't divide by 0, so x can't be 0, 1, or 3. Right? And then the root, the only one, is when x is negative 3. Right? And again, if you chose to write this domain the really long way, you could say negative infinity to 0, skip over 0 to 1, skip over 1 to 3, skip over 3, and go to infinity. I think it's easier to write it the other way, but that's totally up to you. And that is it for the first video.